Good day to you. Welcome to this presentation on closed loop control for ASP. This is James. Let's get started straight away. And look, if you haven't already seen the open loop control level 1 recording, I do recommend you go and have a look at that before studying this one. It's a quite important sort of baseline knowledge for us to have. But again, we're talking about the method by which we take a motor program, which we already know is stored in our long-term memory, and how we translate that into an actual movement. And we said basically how that happens is, we've got these effector mechanisms, which we said in the last recording were nerve impulses and muscular contractions. Effector mechanisms. We've got these effector mechanisms which, once they are instructed to do so by the recall and the retrieval of the motor program, produce a movement. And now I've got the example here of a handstand, okay? A handstand. So we can kind of see that that has happened here as well. This performer has taken the motor program of a balance, a handstand. They've issued that command. The nerve impulses and muscles have produced that movement, and they are in a balanced position. But there's something a little bit different occurring here. There is a second loop other than the effector mechanism, and now back in the opposite direction. Okay, and this loop is what we would refer to as feedback. So first of all, can you please recognize that the notion of a closed loop, which actually I think I've managed to do without a space in there, don't write it that way yourselves, has now got a closed circular loop on this particular instruction to produce movements. That's what we mean by a closed loop. The feedback is occurring. In other words, it is possible, therefore, to do some kind of adjustment during the movement. So there's some kind of adjustment that's possible. So let's think about this in relation to this performer. Okay, they're in this line with their center of mass above their base of support. We see that there. But if this person starts to balance a little bit in the wrong direction, maybe a little bit too far that way, then they can use their core muscles to pull them back in the other direction during the performance. That is concurrent, ongoing, during feedback. Okay, so we get the idea of adjustment, and that means, as I've just said, that this is an example of concurrent feedback. Concurrent feedback simply means feedback that occurs during or while the performance is still occurring. So it's concurrent feedback. We can also say, because we're looking at a notion of equilibrium and balance in this example, or a kinesthetic sense of balance, we can also describe this as a form of intrinsic control. Intrinsic. And that makes sense, right? It's not an extraceptive sort of response where someone's shouting at this performer, or you're overbalancing forward, or no, they're feeling that sense themselves and making the adjustment themselves as well. So what level is this occurring? Well, this is occurring because of at the muscle level. So it's occurring at the muscle. It's occurring at the muscle. So what we mean by that is it's a sense, an intrinsic sense of balance or being out of balance, and it's at the muscular level. The abdominals are going to tighten to actually produce this particular response to do the correcting. So it's at the level of the muscle. Now, because it's at the level of the muscle, and it's not, we're not necessarily sending information back up the brain for a decision to be made, it's also what we'd call a short loop. A short loop. We can make constant and continuous refinements and adjustments. It sounds like this is going to be one decision to balance a bit the other way. No, this is going to be hundreds, maybe thousands of little kind of actions that bring about the constant alignment of this position within this process. And we describe this as a trace. So we describe it as a perceptual trace. In other words, we use our feeling of the skill, our kinesthetic sense of the skill, to respond to the feedback, to refine and adjust the motor program, and then to send a slightly different message via the effector mechanisms to slightly change the movement. This is what we mean by closed loop control level 2. I think other examples which would be considered sort of classics are things such as skiing. I mean, we often use the example of moguls specifically, constant adjustment to keep yourself in balance. When you think about balance in general, this is a good way to think about it. Balance in general is a good one to think about. Just constant adjustment of one's position to keep oneself in a balanced position. That's all from me.